Hello everyone, this is a video lecture for Calculus 2, section 9.1, differential equations, or you can also say diffie-qs. Diffie-qs. There's like DEs, I guess, is another one. DEs. I don't do that one. So, what are differential equations? Well, they have a y prime, and you're solving for y. And so just here's an example. This is kind of like a classic, I guess. We've got y prime equals ky, solve for y. And I mean, I first off think, oh, we'll divide by k. And so then we got y prime over k. Haha! No. You're not done at least. I mean, that might be one step you can do. But it's kind of a weird thing. We have to go down our own procedural route to make this thing work. In fact, this is a pretty cool problem, and it's a classic. So let me do this one with you, just kind of give you a feel of how we're going to be solving these problems. So y prime is equal to ky. Solve for y. And what I want to do here is I want to break this back down, not from Newtonian notation, but to Leibniz notation. And we go back and forth with this in Calculus 1 a lot, so that I hope that you're familiar enough to know dy dx is the same as saying y prime. Either way is the same thing. Well, why do we have one way versus another? Well, this is very obvious. It's simple, it's basic, it makes sense. You can say double prime, triple prime, and it's like really easy to work with. But the Leibniz notation is, I guess you could say, more free. It's free for you to move things around. And in Calculus 1, I don't think we really break this up too much, maybe with implicit differentiation a little bit. But what I'm going to do actually is literally see this as a fraction and start moving things around. So I move these y's to one side and x's to the other. So dy over y is equal to k dx. And that's the strength of the Leibniz notation over the Newtonian notation, because you can do stuff with it. I integrate both sides. And so what I get now, if you look at this, it's technically 1 over y dy, yeah? And then integral of just k. I guess you can even move the k out. So it's like integral of 1 dx. Well, this is an ln of y. And over here we get k, and what's the integral of 1 is just x. Remember one thing, plus c. So we've done the calculus side of things, and that's cool, but I still want to get y by itself. That's the end goal here. To be able to do that, I need to get rid of this ln, and what cancels with ln is an e. And so we have y is equal to e to the kx plus c, and that's all in the power. Now, technically, you're done. You can I don't know, this is not actually a problem, but you could probably type that in and you would get like an answer. That's fine. I don't like leaving it like that. There is one extra step that really helps this problem out, and I'm going to give you the final answer and we'll talk about it. That's my final answer. This is what I like a lot more, okay? Now, why? Well, first off, it gives you a format that you've seen before. A equals A naught e to the kt. Have you seen that? It's exponential growth stuff. Here's another one. A is equal to PERT, the PERT formula, continuous compounding. So there's like a lot of formats that come from this style. So originally, when I looked at this, did you know what that graph would end up looking like? Did you know what this is going to be in the end? Well, it ends up being an exponential growth model. Isn't that weird? Look at this. Is that exponential growth to you? Well, it is eventually. But like initially, when you look at that, it's not something that you think of. It's pretty cool, though, how we just arrived at this. Now, how did I get C to go from here to here? Well, I did a fancy trick. This is actually C1 and this is C2. But it doesn't really matter because C absorbs everything. And so let's go and do the steps here for this so that you're understanding what I'm doing here. I'm going to break this down like this. See how I have a plus sign here? So that's technically going to be two bases multiplied by one another. If I'm multiplying their bases, I'm adding their powers. So I'm kind of doing that in reverse. Well, this e to the c here, that's e to a constant, is itself a constant. And so all I'm doing is I'm putting that one in the front. And then I'm saying, well, you know what? This dude here, he's just a c. C absorbs all these constants. And so again, I know that this is not the same C. And if you were very technical, you would just do C1, C2, and all that kind of stuff. I still don't do that because that's not the point here. This right here is very fine for your answer. And so that's what I was doing. So that's a differential equation. It's a classic one, kind of simple and also kind of interesting. What I'm going to do now is the actual 9.1 homework, which is pretty short. And I feel like it doesn't really get into the meat and taters side of things. The meat and potatoes, the bulk of it, I guess you can say. But at least it's an introduction, and we'll be doing the real, actual math here in the next sections to come, okay? So let's go and do some of these problems. And some of them are going to be silly, and I'm honestly going to be skipping a lot too, because it's just repeating stuff and blah, blah, blah. So they start us out with 9y double prime is equal to negative 25y. And I'm going to ask you, do you know what the answer to this is? Just looking at this, like here, let's go back again. Y prime is equal to ky, and this thing ended up being an exponential growth model. Isn't that weird? So then I say now, y double prime is equal to ky. What is this guy going to be now? Can you tell? This is so funny. This is a sine or a cosine. Yeah, it's a sine or a cosine wave. Isn't that weird? So you'll end up, I mean, plus or minus here with basically this guy. Isn't that weird? I'm just saying, like, looking at this, can you just know what the answer is? In Calculus 2, I'm going to say no. But if you're moving on to higher math classes and like more differential equation classes in particular, then yeah, you will start recognizing these formats. So let's do this problem. It's funny with this here. Again, this is 9-1. They're not expecting a lot out of you. They give you y equals cosine of kt, and that's literally your answer. They say, hey, go ahead and find k. So like, what? So they give you the question, they give you the answer, and then they just say, okay, we'll just go and find k. I guess. So what I want to do is I want to plug this into y, obviously, but I want to also plug it in here. But I'm not capable of doing that yet. I need to actually find y double prime. So y prime, when I take the derivative here of cosine, I get a negative sign. The k comes out to the front. Again, I'm doing chain rule, but I'm doing it kind of fast. This one here, the negative sign turns into a negative cosine, but the k comes out to the front, making a k squared. So I'm doing chain rule. I'm just kind of throwing it up there super fast like. So this actually, you can plug in right there now. So I got 9 negative k squared cosine of kt is equal to negative 25 of cosine of kt. And I want to solve for k. This 9 here and this stuff here, it's just numbers in the front, but they both have this cosine, which you can actually cancel out, thankfully. Divide by the 9, I guess, and you don't need the negative on both sides, so k. Actually, need to get rid of that. K squared is equal to 25 over 9. Square root both sides, and what we get is k is equal to plus or minus 5 over 3. Now, I don't have an actual boxed answer on this, and that's kind of weird. I almost always box my answers in to say, look, this is actually the answer. I instead circled it. Now, it could have been, like, I guess a typo in a way. I can't remember this problem exactly because it's been a couple months since I've done it. But I'm looking at my notes here, and that's it. We're done. There's nothing else to do. If they actually ask for you to type this thing in, then perhaps you want to try something like this into the box, or you click that as an answer, or they might discuss something about it being positive only if you do this and that constraints. There's always a little bit of talking going on with the 9-1 problems. So regardless, this is my answer, and I go away. Yes, I have a note here. It says lots more to this problem, but it's a copy-paste kind of stuff, so I'm not doing it. Okay, that's fine. 91017. And so I've got y double prime plus y is equal to 3 sine x. And they give you a list of options about what the answer could be. And so I've got 3 sine of x, 3 cosine x. I got 3 halves x sine x. And then I've got negative 3 halves x cosine x. They say, which of these actually gives you the answer? I'm going to give it to you. It's this guy. How do you know that this is going to be the answer out of all these options here? Well, just like the last problem, I'm going to plug this guy in, and I'm going to have to find my y prime, my y double prime, and I'm going to plug that in, and then I just solve and blah, blah, blah. It's identical to the last problem. It's just that they say, instead of giving you the actual answer up front, they say, well, any of these could work, so all you're doing is the same as the last problem 4 times. And if it equates, then you're good. If it doesn't work, then you're not good, and you don't use it. I'm just also going to say that some of these you can look at, again, if you're super skilled here, where these are not going to work because they're too simple. If you had y double prime equals y, like I was saying, then yeah, it's probably one of these guys, and then you can talk about it and blah, blah, blah. But notice that we have an additional component here to this. They just tack on an extra sine x. So that's going to add more complexity, and so I'm already thinking it's going to be one of these two guys, okay? I'm not doing any more to it. It's multiple choice. In the end, couldn't you just click, 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 and eventually get it right? But the idea is that you're testing each one individually and eventually getting it. Okay, the next problem. Again, I have another note. I'm not doing most of this, but the end is weird. So I want to talk about the end, apparently. You can see that I'm not trying to get away from doing work here. It's just the fact that I'm really not wanting to give away, like, this is the answer. I want you to kind of discover how this works, okay? So it's kind of a discovery homework. Anyways, the last part is kind of weird. This is an ln, and I have to solve for something. They say I have an initial condition. Later on, that'll be IC. I don't know how often we use it in this class, but differential equations, it's initial condition of y of 1 is equal to 2. And they want to solve for C. And this is a classic situation. Say we have an answer, blah, blah, blah. We did all this math, and we get to this guy, just like we did on the very first problem. Just like that guy in the first problem. And we need to solve for C. We need to be able to figure out what the C and maybe even the K would be in order to figure this problem out, right? So that's what we're doing here. Notice that this right here is an X value, and this is a Y value. And so I'm going to just plug them in as you see them. 2 is equal to 5 times ln of 1 plus C, all divided by 1. Well, you don't need to divide by 1. That goes away. Ln of 1 is actually a 0, so that goes away. So 2 is equal to C, and the answer that you have to type in here now is the same as the answer given, but with that 2. And do notice that I have the y equals included in the box. They're probably going to be wanting that. So the next problem we got is 91020. I've got y prime is equal to x y cubed all over 4. And then they say y naught is equal to 4, solve for y. So this is our very first, on the homework, differential equation that we're going to be solving together. And that's pretty cool. Problem is that this is probably the hardest one that you might be doing in the whole chapter. Not really. I mean, there's a couple that are harder, but this is seriously one of the harder problems, not just in this section, but for like sections to come. And so I don't know why it's like all of a sudden, boom. But we're going to do it together, of course. And maybe there was a technique that I was missing or something along the way. I don't know, but I'm going to do it with you, and we're going to figure it out. In the end, it's not super hard. So we're going to have to do this thing called separation of variables, and that actually I think is the title to one of the next sections coming up. Not the next one, but the one after that, I believe. something like that. We're going to definitely be seeing that as a technique. But right now, what I want to do is I want to get y's on one side, x's on the other. And so to do that, I'm actually going to take this y cubed to the other side and leave everything else alone for just a minute. So I got y prime over y cubed is equal to x over 4. Well, I can't leave it like y prime. That's technically a dy dx all over y cubed. And so I'm going to take this is denominator, with the y cubed technically. I'm going to bring him to the other side like that. And so we get dy over y cubed is equal to x over 4 dx. And then I integrate both sides. Sometimes whenever I write dy on top or dx on the side, it might not seem as conventional. So it kind of skews our brains from the simplicity that you see. So for example, this guy right here is actually just y to the negative 3 dy. And this one over here is a 1/4 in the front integral of x dx. This is not hard. I'm just going to add 1 to the power, divide by the new power. So I add 1 to the power, divide by the new power. Over here, I add 1 to the power and divide by the new power. And then plus c. Got to remember the plus c. Now this looks kind of junky. And of course I need to go and solve for y now. That's why it was one of the more difficult ones here. Because it's junky. A lot of stuff to do here. When I move this 2, it'll actually be in the numerator, and what happens is that this 2 and this 2 cancels, but the negative still moves over, making a negative 1/4 x squared, and then still plus c. Now, here's the thing. The 2 technically also moves to the c, so this is a c1, and this is c1 divided by multiplied by negative 2. But yeah, it absorbs it, so I could call it a c2. Again, though, I don't do any of that. The c just figures itself out. Rarely would you ever have an actual issue with that c. This is, again, technically in the denominator. And so what I need to do is solve for y. I'm going to actually move this over here and take all of this and move it down there. And so we get y squared is equal to 1 over all this stuff. The c is not on the outside anymore. He's actually inside like this. It's important. Well, how do you solve for y? How do you do it? Square root both sides, right? Yeah, of course. So when you square root both sides, you got a plus and a minus. And this here is the answer. Kinda. So they want you to solve for c because they gave you an initial condition here. Notice that we have an x and a y value. I zoomed in. So my point is 0, 4 essentially. Let me go and plug that in down here. So my point was 0, 4. And I'm going to plug those things in. So my y is 4 plus or minus square root of 1 over negative 1/4 times the 0 squared plus c. And I need to solve for c. Well, the plus or minus kind of makes me a little weirded out. I'm kind of a little strange. I mean, what do? Do I say minus plus to the other side or whatever? I don't really know. But I can at least square both sides. And so what I get is 16 is equal to, and square makes this go away anyways, of 1 over, and that's a 0, so it goes away. So c. If you move this down and around, your c is equal to 1 over, I don't have that. I have a 32. What did I do wrong? Oh, it's a different c. Okay, I already saw it's c1, c2 kind of issue. Yeah, this is fine. Cool. And so then I can plug it back into my answer, plus or minus the square root of 1 over negative 1/4 x squared plus the c. Yay! Oh, no, wait, I'm sorry, the c. 1 over 16. Yay! All right, here's the thing. One of these is wrong. There's a plus and a minus, and they only want one answer. And it's actually just the positive answer. Now, it's not just the positive just because, well, of course it's just the positive. That's a bad assumption. What's going on is that my 0.04 is actually yielded from a positive square root blah blah blah. Notice that this is a 0 and I got a positive 4, not a negative. So this here, this square root should yield an absolute value, a positive, and then I get to decide which sign is in the front. And so I'm deciding here from the initial condition that it's a positive, therefore I have to choose that positive there. Okay, like literally this positive sign is that positive sign, literally, literally, literally. Those are literally the same thing, okay? It's the same as that positive sign. They're all the same. The 4 is this thing. This whole huge thing, that's a 4. And so that's my final answer. Positive square root of 1 over all this stuff. Now, I have a different answer written in my notes because I solved it a little bit differently. But they have probably a totally different answer on WebAssign. I don't know. So there you go. We did it. We've solved it. We're done. You plug it in. Everything should be fine, okay? Now, I have a note here to say, look at the graph. I don't really know what the graph of that looks like. I'm not going to go into it. We'll see graphs later. Graphs will definitely come later in another section. Okay. 91021. This is a classic problem here, and they don't even do anything classic about it. Yeah. It's like a cool classic car, and they're like, "Oh man, well, can you start it up and we can go drive it?" And they're like, "No, I don't want to drive my classic car. I just want to look at it." And that's okay for some people, I guess. Maybe it might break. I don't know. But this is a classic problem here, and they don't do anything with it. It's kind of silly. They say, "Cool. So when is P increasing?" And then when is P decreasing? And where is the equilibrium? You can't see it, but whatever. Equilibrium. We'll discuss that. What they're wanting to know is, first off, equilibrium, and then we can go backwards and find where is it increasing, decreasing. And what they're wanting for most of these answers are intervals. And so we're going to definitely say find the points here. These are points. And then they create intervals around them. So what does it mean to be equilibrium? Well, essentially, I'm going to find that this guy here is equal to 0. And so I have 1.1 p 1 minus p over 4100 is equal to 0. And so this guy here could mean that p equals 0. Because again, this could be equal to 0, this could be equal to 0, all the factors are equal to 0. Or it could mean that this guy is equal to 0. And so what I'm going to do is move this guy over, of course. Multiply. So we get this answer and this answer. Those are actually the answers for part C, the equilibrium. P equals, and they have a box, and you put 0, 4100. Okay, so how do we do part A and B? How do we find the increasing, decreasing stuff? So what I do is I plug in P equals 1. And I just want to see what's going on at P equals 1. So I got 1.1 P, 1 minus P over 4100. So when I plug in a 1, I get 1.1 times 1 over 1 minus 4100. And I don't have the value of that, actually. So let me type it in my calculator right quick. And I get 1.09973. Cool. I don't care what the number is. It's a positive. It's a positive. And so what does that mean about increasing, decreasing? Well, kind of go back for a second. This was dp/dt, right? At the very, very, very beginning. This is a derivative. This is a slope. And I'm saying that my slope in this particular case is positive. What does that mean? It means it's going up. It means it's increasing. So it's increasing at p equals 1, increasing. Well, because we already found the equilibrium points of 0 and 4100, 0, 4100, and I said, well, let's try right here at p equals 1, and I found that it was increasing. Well, that means anything in here is increasing. It was just a test point. And if you go and test, say, I don't know, something over here, 4101, you test this, what you'll find is all this stuff over here is decreasing out until infinity. And so here's my part A and B answers. Increasing is going to go from 0 to 4100. Notice that I'm not including either of those particular points because those particular points were equilibrium points. They're when it's equal to 0, slope equals 0. And then my decreasing would be 4100 out to infinity. And then part C I already gave you. So cool. It's a lot cooler with the graph. And again, like I said, this is a classic problem they had, and they did nothing classic with it. So we'll be seeing that problem again for sure. And we'll actually be solving it in a really neat way. Okay, so don't worry. We'll do it later. Okay. dy dt is equal to y to the fourth minus 14y cubed plus 48y squared. And they say find the constant solutions. Constant solutions. Again, this is just trying to say set this equal to 0, which is silly, and we can discuss that another time. But the math side is very simple at this point. It's algebra, which we've done before many, many times. And so we got y equals 0. And this guy factors to be y minus 8 and y minus 6. And so then we got y equals 8 and y equals 6. And so my final answer is 0, 8, and 6. And that's it. That's the end of that problem. Seriously, nothing else. And I don't know why we got 0, 0, 2 here at the very back end, but that's fine. X, y prime plus y is equal to 8x. This is a really neat problem. This is super, super cool. This is not what we're actually going to solve at all. They give you a lot of options here. And so I'm not going to even list out these other options. I'm just going to give you the last one, which is the answer. So just like the previous problems, that you find, you pick one and you say, oh, well, I got my y, I can plug that in. And then you say, well, y prime is equal to, and you plug that in. And then you just see if it all makes sense. Like, say you get 0 equals 0. That's a true statement. What if you got 2 equals 0? That's not a true statement. So look for the one that gives you a true statement, click it, and you're done. That's all I got. That's all I got in this section. It's very fast and easy. So thank you very much. Have a great day.